the Arctic Ocean, a silent, cold, bleak, icy wilderness. Although the area has long been of interest to scientists, access to the region has been extremely limited. Now that's all changing. And what you hear is the sound of change. The sound of a United States Navy nuclear attack submarine surfacing through the ice in the Arctic Ocean. A submarine surfacing not for military defense, but for civilian science. The Navy is letting civilian scientists use submarines such as this for Arctic expeditions. Scicex, the Navy's submarine Arctic science program, is making it easier for scientists to collect data and conduct experiments at the top of the world.
Officer of the deck, passing course 270 to the right. Very well.
Scientists such as Dr. Ted DeLaca, chief scientist aboard a recent Arctic Ocean submarine expedition and director of the Office of Arctic Research, University of Alaska, Fairbanks.
The U.S. and international science community interested in issues related to the Arctic have long wanted to get to the Arctic Ocean and take studies there and become involved in studies. And they have been thwarted by a lack of logistical support. Many of us were interested in some of the logistical capabilities of the Department of Defense, and we asked whether we could have access to nuclear submarines, aircraft, ice camps, and other activities that were going on. And we finally got access to those. And so what Scicex is a program to provide logistical support from the Navy, the submarine service, to the scientific community in academia.
The cost to independently set up and logistically support complex ice camps such as this Navy camp is out of reach for most, if not all, research programs. The Submarine Arctic Science Program provides a very cost-effective alternative. The goal of the program is to improve understanding of Arctic Ocean processes and their role in the Earth's climate system by fully capitalizing on existing national platform capabilities. The program will provide a fantastic increase in our ability to monitor the changes that are going on in the Arctic above, on, and under the ice. In 1993, the submarine USS Pargo, with civilian scientists aboard, spent 21 days collecting scientific data to demonstrate the concept. Dr. Peter McCroy, professor of marine science, University of Alaska, Fairbanks, was on that expedition.
The first mission was very scientific. It was much more limited than the second scientific cruise on the submarine. But because it was tested, they intentionally limited what we could do. We collected, I don't know, it was about 2,000 samples for various aspects of water chemistry and biology. There was a continuous profiling of sea ice conditions, ice thickness, and also the seabed, continuous geophysical survey of the seabed. They had fun, in fact, supporting our program. We weren't in the way. We did not cause difficulties for their other missions that were still ongoing during our stay on the ship. And they found out that not only was it possible, that it was exciting, that they could use their platforms for a lot more information than they thought, and it didn't detract from the Navy's overall priority missions. So off we go.
The following year, USS Kavala, SSN 684, sailed from Pearl Harbor, Hawaii with its 128-member Navy crew for Submarine Science Cruise 95. Scicex 95, the first of 5 planned annual deployments to the Arctic in support of civilian scientific research.
If you haven't noticed, I have, because I got my long underwear tops on now, that it's getting much colder on the boat. Like the XO said, that means we must be heading in the right direction. So we're almost there. We'll run drills for another 2 days, and then on Wednesday we're going to set the Arctic Ops routine as we pass through the Aleutian Islands, and we'll be there. Another day or so after that, we'll be under the ice line. So start thinking Arctic Ops.
The Kavala, a Sturgeon-class attack submarine, carried 4 university scientists on the 2-month expedition under the ice. The scientists collected data supporting 16 scientific investigations. since a major activity on the cruise was the acquisition of scientific data 24 hours a day. 3 Arctic submarine laboratory personnel also deployed with the ship to provide full-time facilitation of the science and to act as liaison between the senior scientist on board and the ship's commanding officer. In order to fulfill her scientific objectives, Kavala traveled almost 11,000 nautical miles, traversing most of the deep Arctic basin and surfacing at 5 remote locations to establish temporary ice camps. During the deployment, studies of Arctic Ocean circulation were conducted through the acquisition and analysis of large numbers of water samples from various locations and depths within the data collection area. Horizontal and vertical conductivity and temperature profiles were measured using expendable probes and hull-mounted sensors. Continuous low-light video and high-frequency side-scan sonar recordings of the underside of the ice canopy were made, and the submarine surfaced in the ice to implant satellite reporting oceanographic and meteorological buoys.
The feature starts tomorrow night, about 1900. So we'll be in the same kind of routine that the first one we find that the ice is the right thickness and it's big enough to park the boat in, we're going to surface the ship. Line us up with the feature. Counting officer will order up all stop and slow us down to less than 3 knots. As we go below 5 knots, we'll be rigging out the outboard. When we get down to a speed of 3 knots, we'll begin hovering, and then we'll slowly make the approach into the feature. Carry on.
Yeah, the curve's offset this way. Center of feature bearing 1,100 yards.
During the deployment, scientists investigated water mass properties with special emphasis given to near-shelf and frontal regions, geophysics with special emphasis on the bathymetric features of the Chukchi borderland region, and ice mechanics. Distribution, thickness, and topography of the ice pack are principal drivers for the overall Arctic heat budget and for acoustic propagation. The submarine's upward-looking acoustic and video sensors make it uniquely suited to provide information on the structure, distribution, and draft of the pack ice over large portions of the Arctic.
The Arctic Ocean has interested the scientific community for many years. More recently, with the increased interest in potential of global change, modelers have been looking at the Arctic and the Antarctic with greater interest because early models, which are relatively crude when compared with what we need to make the kinds of decisions that society will have to make in the future, I have pointed towards the polar regions as being the most important regions of the globe with regard to change. And the Arctic is far more important and will be important earlier than the Antarctic. When, however, we turn as a group to examine some of these early findings, we find that we really don't understand how the Arctic works. And so there has been a movement recently to try to gain that kind of information. We have, however, been frustrated by the lack of logistical support. And the issue we're talking about today, the use of nuclear submarines to provide this kind of support, becomes critical.
The nice thing about a submarine is that it has freedom to roam the Arctic, which a surface ship, like an icebreaker, is much more restricted because it needs fuel and it needs to go where it can go. The ice is a very restrictive to navigation in the Arctic, and an icebreaker just can't go everywhere. There's a great deal of interest in the seafloor in the Arctic, and this is the last unknown turf of the planet of how the plates move and how the Earth is structured from that. So a submarine, because it has the freedom of navigation, can do transects of geophysical data that were not even thought possible before, and probably aren't possible with any other kind of platform.
It only takes a brief look at the map to have people become more aware of the extensive nature of the shelves in the area, their potential for organic content and the evolution of greenhouse gases. For the ice cover, which we understand may not be as permanent and as stable as we would all hope, to try to find out what its dynamics and its mass balance might be. Even the movement of the water in the basin, this large Mediterranean-type ocean, is not well understood, let alone the biology in it and a variety of other factors related to it. Atmospheric studies, solar terrestrial interactions, all of these things are screaming out to be done. And what we must do is to capitalize on opportunities such as this one and try to encourage others as well.
4 additional annual cruises to the Arctic are planned. Each provides unprecedented opportunity for scientists to conduct Arctic research projects which would not otherwise be feasible. You, your university, or research organization can take part in the program. The Office of Naval Research, in a broad agency announcement published in the Commerce Business Daily, announces the approximate schedule, the opportunity to participate in availability of funding, and solicits proposals. O&R chairs a science steering committee with members from each of the funding agencies, plus representatives from the National Academy of Sciences. This committee ranks and selects proposals for funding and proposes the selected experiments to an operational planning board chaired by the Chief of Naval Operations. The Operational Planning Board reviews proposed experiments for operational feasibility and safety. Space aboard a nuclear attack submarine is scarce, and available space for scientific personnel and additional equipment is extremely limited. The number of scientific personnel is limited to those absolutely needed to accomplish the goals of the science program. Those scientists who are selected to embark on the submarine, assisted by the embarked Arctic submarine laboratory personnel, will collect data for all of the scientific experiments. The nuclear submarine truly offers a unique data collection opportunity, enabling scientific studies which would otherwise be impossible. The Submarine Arctic Science Program is providing an opportunity for scientists to conduct studies in an otherwise inaccessible region of the world at a time when those studies are vital to the understanding of our ecosystem. Scicex 95 is now history, but there are more to come. The next time a Scicex submarine surfaces through the ice in the Arctic Ocean, your experiment could be aboard. If you're interested in additional information about the Submarine Arctic Science Program, contact Jeff Gossett, Head of Fleet Operations, Naval Undersea Warfare Center Detachment, Arctic Submarine Laboratory, San Diego, California. The Scicex program is jointly sponsored by the Chief of Naval Operations, Commander Submarine Force U.S. Atlantic Fleet, Commander Submarine Force U.S. Pacific Fleet, the Office of Naval Research, the National Science Foundation, the National Oceanographic and Atmospheric Administration, and the United States Geographic Survey. Special thanks to the crew of the USS Kavala, the assistance of the University of Alaska Fairbanks, who provided the video interviews of Ted DeLacca and Peter McCroy, is greatly appreciated. The video was produced by Video Presentations Incorporated, Honolulu, Hawaii.